Hello, everyone, and welcome to today's SANS webcast. Secure by default, scoring the big three cloud providers. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Brandon Evans, SANS Community Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Brandon.
Hey, thank you so much, Carol. So thank you everyone for tuning in. I'm really excited to discuss this topic with you all. Before we get into the presentation, I wanted to briefly plug the course that I teach for SANS, Sec 540, Cloud Security and DevOps Automation. If you're a security professional and are not well versed in the way of DevOps, you are prescribing solutions for problems and teams that don't exist anymore. Sec 540 gives you the context and the practical skills to play in that space. The lab architecture is deployed on premises, in AWS, and in Azure, giving you real-world examples of how to utilize these skills across multiple environments while learning core cloud concepts. For the more advanced students, there are a plethora of challenging tasks you can tackle in NetWars, which runs throughout the week. Implement security controls in the cloud using code that you can copy and paste into your organization's infrastructure to win this awesome challenge coin. For more information, go to sans.org/sec540. So, some details on myself. My name is Brandon Evans. I come from a developer background. I've worked on a variety of teams that follow DevOps practices. Most recently, I worked on a product development team at Azure that was primarily based in AWS. At some point, I determined that I liked breaking things a lot more than I liked building them, so I moved over to the security world. In addition to my full-time job, I'm also a SANS instructor and have taken a variety of GX certifications. Last week, I took the beta exam for the GCSA, or GIAC Cloud Security Automation, which is the certification for 540. I won't learn my score until April, but here's hoping that I passed. So before we get started, I want you to picture this scenario. You're a developer in a small team. It's Friday afternoon. You just can't wait to go home at 5 o'clock so you can prepare for your Super Bowl party that weekend. All of a sudden, your least favorite project manager comes over to your desk. It turns out they had made a client commitment due today that you're only now just learning about. You want to tell the project manager off for being so cavalier about volunteering your team's time without consulting you, but you quickly realize that you don't have time to argue. Your organization has embraced the cloud, and because the request is fairly simple, it's easier for you to fulfill the request than to waste time discussing the request. So you just go into your cloud's web user interface, you fill out a quick setup wizard, and you're up and running with the infrastructure that you need. Your team accomplishes the job just in time to clock out for the weekend. All is well, and then, bam, you see a headline like this about your company. We've become desensitized to breaches being caused by insecure cloud configurations. This is an actual, real headline, by the way, that came out recently. Historically, much of this was caused by services that are insecure by default. Over time, the cloud providers have improved here, but there are still many services that require extra work to lock down. Even the most secured services are easy to open up. And when a developer is in a pinch, given the option to save some time by checking a box, they have every incentive to do so. This problem is going to get worse before it gets better. AWS alone has 175 services and counting. When I checked the statistic 2 months ago, the number was 165. This is exciting for innovation, but it's also scary for security. When assessing a new service, do you think that the product development organization is going to vet it for security before adopting it? Probably not. Even those who look out for security settings will oftentimes find that they are completely missing when the service is first introduced. When they get introduced a few months later, the users might never go back to adopt them. This is the best case scenario. Even some of the core cloud services are hard to lock down. I learned that the hard way when I was assigned to get an RDS instance in compliance with Azure's strict security policies. I was simply blown away with the level of effort necessary to lock it down. I should not have to do any work to add basic foundational security to a cloud service. And if any configuration is necessary, it should be as simple as checking a checkbox or adding a single line of code to my configuration management. As you'll see in a bit, there was a little bit more to it. When I lamented about this to my former director, Nick, he was surprised that no one had written about this before. So I fixed that by writing an article of my own. This talk is an outgrowth of that article that seeks to answer a simple question. Is AWS uniquely bad at creating services that are secure by default, or does every provider get this wrong? Some people might not see the value of this talk. Of course, any tool used inaccurately can cause security problems. We shouldn't be using the default settings of any cloud offering. Instead, we should define the best practices for these tools and use infrastructure as code to ensure that they are followed. I completely agree with you. When you figure out how to do this across your entire enterprise, please let me know and then pinch yourself because you're dreaming. Even if you accomplish this, you're constantly playing catch up because new services are launching all the time. Can you determine the best security practices for a new service and create paved road libraries for them before the product development organization adopts them? That's extremely challenging. Additionally, even if you've sorted that out, your most powerful tool is infrastructure as code, and there's no guarantee that your toolkit of choice will be updated to support the new service in time. For these and many other reasons, we need to ensure that the path of least resistance is secure. Oftentimes, that path is the web user interface for your cloud provider. Unfortunately, we are generally lacking in ways to remove insecure options at the account level. So, we should assume that any default setting can and will be used. What risks does this expose us to, and can we accept them? That's what we have to ask. Realistically, this talk isn't going to convince you or your company to switch cloud providers. At most, it will make you think twice before you're selecting a provider for a new initiative. Once you've invested into a provider, it's unlikely that you're going to switch, and I totally understand that. However, that doesn't mean we can't push our providers to do better. In this talk, you're going to see some default settings that your providers chose on purpose that will boggle your mind. You should let them know. They have an incentive to listen. They make changes all the time based on user feedback about service functionality. Let's encourage them to make changes that actually improve security. Failing that, I hope that they will give us more capabilities to define our own defaults for our accounts according to our risk tolerance. So the majority of this talk is going to be comparing services from the big three providers. Here are some ground rules before we get started. Firstly, I will attempt to compare services that serve the same purposes. I wouldn't compare AWS S3 to Google Cloud Functions because they do completely different things. Instead, I will compare S3 to Google Cloud Storage because they serve the same purpose. Next, I will avoid discussing proprietary solutions in this talk where possible. If I got to discuss offerings that were exclusive to one provider or the other, I'd probably spend most of this talk ragging on Google's Firebase offering. Instead, I will discuss their managed PostgreSQL services because Postgres is open source and is available on all three platforms. I will be judging these services in one or more ways. For example, I will be discussing the various serverless function offerings and will rank them based on their access control, management, and execution role permissions. These categories might seem arbitrary, and that's because they are. I'm only going to contrast the offerings if they differ in some significant way, and there may be multiple ways in which they differ. I want to ensure that a given service is given praise if they succeed in one area and fail in another. For each category, I will award 2 points for the best offering, 1 point for the second, and 0 for the third. Ties are allowed, meaning that if one service is uniquely bad in some way, I could give it 0 points and the other two offerings 2 points. At the end, we will tally up the scores. I'm going to try to make my arguments objective, but I know that pure objectivity is impossible. To be transparent, here are my biases. I currently work predominantly with AWS, I have used GCP for some of my personal projects, and I used Azure exclusively at my previous company. There is no way to make this 1-hour talk comprehensive. I focused on some key services, which are highlighted on this slide. Without further ado, let's get into the nitty-gritty. Let's start with the most infamous category, file storage services. Perhaps the most infamous security problem in the cloud is allowing unnecessary access to files in storage accounts. ThreatPost reports that 2.3 billion files were erroneously exposed in the 12 months prior to May 2019. You hear about leaky storage accounts almost every day. In December of 2019, a Sprint contractor leaked 261,000 Verizon, Sprint, AT&T, and T-Mobile. Thankfully, this Sprint contractor wasn't Asurian, but nonetheless, it's rough for the entire world. Every provider has gotten better at preventing this. Currently, all files uploaded to the big three are private by default. This doesn't mean our problem is solved, clearly, as eventually you are going to need to expose that data intentionally. The different providers have different access control options for legitimately sharing files. Which one makes it easiest to go wrong? S3 is the first service that comes to mind when people discuss cloud file storage. Although it definitely wasn't secure from day one, they've made a lot of improvements. As long as I can remember, S3 made uploaded objects private by default. This can be overridden, of course, and oftentimes we do so incorrectly. This has become so endemic that AWS has introduced new functionality to override all settings that make objects public within a bucket or an account. Although they provide a lot of different fine-grained settings, I personally find that they can be confusing. There's a lot of detail here, which means that you have a lot of control, but it also means that you can make a lot of mistakes. For example, an infamous setting, which since has been removed, allowed users to grant access to a bucket for, quote, any authenticated user. To the average person, this might sound like you're granting access to all users in your account. No, you're actually granting access to every single AWS user in the world, which functionally means everyone because it's free to set up an AWS account. Regardless of your access control, at the network layer, S3 buckets are always accessible to the public internet, which is not atypical for these kinds of services, as we'll show shortly. AWS is well aware of this problem. This screenshot, which was taken directly from the Sec 540 slides, shows that it's taking proactive measures to contact its users with bad configurations in order to prevent additional leaks. This is great, but this problem is a complex one that doesn't get solved by a single defense mechanism. There's just no way to have a silver bullet here. Next, let's talk about Azure. Like AWS, Azure prevents you from making objects public unknowingly. You can still make a container or the individual blobs accessible to anonymous users. In my opinion, these controls are a bit more straightforward, but this is definitely subjective. Unlike the other two providers, privacy is all or nothing in Azure. A container is either public or private. However, you can choose to either expose the metadata for the container or just the blob objects. Additionally, Azure offers the ability to restrict access to a container to within a private network. However, this is turned off by default and certainly would require some effort to enable. Finally, let's discuss Google Cloud Storage. Google makes all buckets and objects private by default. A bucket can either have uniform or fine-grained permissions. By default, it's fine-grained, meaning objects in a bucket can all have different permissions. I personally think it would be better if uniform permissions were used by default. Otherwise, it's difficult to catch single sensitive files that are public in a bucket. There isn't a one-click way of making a bucket or object public, though. You have to add a member in the permissions, and specifically assign either all users or all authenticated users to the storage object viewer role. If you purposefully do this, you will get a warning message like shown in the slides. So I don't see a clear winner here without resorting to discussing my personal opinions, so I'll make it a three-way tie. That way, everyone can be at least happy about one of my decisions. With that out of the way, are folks ready for some controversial hot takes? Because get ready, they're coming. Next, let's talk about the virtual machine offerings for each provider. Specifically, we are going to talk about the ability to SSH into a newly created virtual machine. Here's a quick overview. SSH is the secure shell protocol, which you can use to get shell access on a remote server. SSH has a lot of security built in, including strong authentication with asymmetric keys or less strong authentication with a username and password combination. Regardless, you don't want to have your SSH server open to the public internet. Only those who need to manually administrate the servers need this access. It's important to lock this down because there has been malware that attempts to steal SSH keys since at least 2014. SSH is also susceptible to person-in-the-middle attacks. Even if you don't believe that this is a real security risk, it's definitely going to show up on a security audit. So let's sidestep the issue altogether by either removing SSH access or limiting access to a specific list of networks. First, let's discuss the Amazon Elastic Cloud Compute Service, or EC2. By default, when you're configuring security groups for a new EC2 instance, you'll be presented with this default security group. This allows any access your SSH server if they have the associated credentials. This is unnecessary access. Even if you truly need to SSH into your production hosts, there's no reason why everyone in the world needs to. As such, it's much better to lock down access to specific hosts. The good news is that you only get the security group if you actually go to step 6. You see, you can actually skip from step 2 all the way to step 7. And if you do that, it will default to having no security groups. But then again, what use would an EC2 instance be with 0 network access? Additionally, they have this warning message that clearly states that this security group is not recommended. That being said, if they know this is insecure, why do they provide it by default? Why not require the user to set this insecure security group up manually if they actually need it? Otherwise, the developer is likely to say, sure, whatever, okay, I'll take the security group, and then proceed to the next step. Azure is very similar. By default, it allows inbound connections on port 22 from the entire world. Like AWS, it has a pretty clear warning message here. Unlike AWS, though, there is no way to skip over this section. So when I launched a VM on the Google Cloud Compute Engine, I was optimistic. There was a firewall section, and all the rules were turned off by default. Great. So I then tried to SSH into the instance using the external IP, and it worked. That doesn't make any sense. The firewall section in the wizard didn't even give me the option to enable SSH access. So it turns out that for your convenience, Google added some default firewall rules that are applied globally to all virtual machines. Do you want to see what those rules look like? I hope you're sitting down because you're going to faint when you see these. That's right, folks. Without telling you, Google allows inbound access over the TCP ports for both SSH and RDP. Additionally, it allows all ICMP traffic. Now, I know that it's a common troubleshooting step to ping Google in order to troubleshoot a network, but not like this. We don't need to specifically ping our virtual machine. This is very bad. Not only are these firewall rules problematic, but you wouldn't know that you had them unless you went searching for them. If your organization is currently using GCP, I strongly recommend that you log in as soon as possible and remove these default firewall rules. One final note on this topic, Google has a cool feature that allows you to SSH into your instance via their web-based cloud console. In theory, this would allow you to restrict all SSH traffic to go through GCP. There are only 2 problems. 1, as of last weekend, this feature wasn't actually working for me. And 2, there's no practical way to configure your firewall to only accept GCP traffic. This feature was requested on Google's official issue tracker in February of 2016. It was last bumped in September of 2019. The issue is still open today. To quote the creator of the issue, quote, "I honestly can't tell my customers that GCP is just as secure as their own environments in the data center right now," unquote. So I couldn't give Amazon and Azure the gold medal here because they both have some pretty glaring issues, but Google clearly belongs at the bottom of the pack. So I settled on giving Amazon and Azure both silver medals, and I gave Google the bronze. Next, let's discuss some database offerings. In this section, we're talking about the security of the database server's underlying file system. It's necessary to encrypt the underlying disk in order to prevent data loss in the event of a physical server being compromised, as well as for compliance purposes. We are not discussing record-level encryption, meaning the encryption of individual records of data stored in a database. I have yet to see a cloud-based solution that solves this problem by default. Instead, most organizations implement this in their paved road application libraries. So it should be fairly easy to ensure that our database disk is encrypted. Which provider has the fewest pitfalls? Let's begin with AWS's offering, RDS, which stands for the Relational Database Service. When I first researched this topic, I would have said that AWS was the clear loser, but I have to give them credit for improving their defaults here. Previously, by default, your underlying instance wasn't encrypted. Now, regardless of whether you use their standard create or their new easy create wizard, the volume will be encrypted with the default RDS KMS key, which is managed by AWS. You can alternatively use a different KMS key that you define. The key material can be managed in AWS or externally. If you have a valid reason to turn off encryption, you can do so. However, the UI is now laid out such that it's very difficult to do this by accident. So that's really nice. The section on Azure was pretty difficult to research because Azure's jargon here is fairly weird. Here's a fun fact. Azure SQL and Azure Database are two totally different offerings. While Azure SQL, their managed MS SQL service, offers the granularity that AWS RDS does, the offerings for PostgreSQL, MySQL, and MariaDB uses an encryption key that cannot be removed or modified. This means it's impossible for organizations to accidentally leave the file system unencrypted, which is good. However, this lack of flexibility will render this offering unusable by companies with contractual agreements that prevent them from creating their key material in the cloud. From everything I can see, Google Cloud has basically the same storage security as Azure. Encryption is on by default, and it's not configurable. There's not much more to say about this section. Assigning winners and losers here was difficult. Technically, all three solutions are now secured by default. However, the degree of security is debatable. There are many people that would argue that it's unacceptable to have your encryption key material originate in the cloud, and that's definitely up for debate. For this reason, I give RDS the gold for giving organizations the flexibility they may need to use their own key material. I also like that RDS gives you the option to use different keys for different instances, meaning that in the extremely unlikely case that an AWS managed key is compromised, not all of your data would be compromised. The other providers do not provide this flexibility, but they do a really good job, so I believe they should be tied for second. Next, let's discuss database transport security. Your data security at rest is important, but so is data in transit. We don't want a third party to sniff our network and exfiltrate sensitive data. Worse yet, depending on your configuration, your Postgres client might even send your credentials over the wire in clear text. Additionally, a person-in-the-middle attack can compromise the integrity of your data and its audit logs. Let's see how the big three handle this problem. We have some good news and some bad news. The good news is that all the providers support SSL TLS connections by default. The bad news is that you can still use insecure connections by default. This is odd, as Google Cloud's own documentation states, quote, if you do not require SSL TLS for all connections, clients without a valid certificate are allowed to connect. For this reason, if you are accessing your instance using IP, it is strongly recommended that you enforce SSL for all connections. I'm not sure why insecure connections are allowed by default. Perhaps that there are latency concerns, but I can't imagine that they outweigh the disadvantage of data loss. More importantly, most of the clients I've seen use secure connections by default, so the people who are connecting over an insecure channel are probably doing so unintentionally. So it shouldn't be surprising that I don't like AWS's solution, given that I wrote an entire article on it. Instead of providing a top-level setting like they should, AWS provides a huge list of parameters that you can configure in what are called parameter groups. The setting to require SSL TLS is buried under literally hundreds of other settings. When I first took this screenshot, it was on page 12, and each page contains 20 settings each. As of this weekend, it has been pushed down to page 13. Very difficult to find this setting, much less change the setting. Side note, as it's out of scope for this talk, but this process is even worse if you're using MySQL or Aurora. When I researched this in late 2018, they had a different parameter called require secure transport, but it wasn't actually modifiable. It seems like they have since removed that parameter altogether, presumably because it didn't do anything. Your only option is to run a query on the database directly. This is wild because Aurora is Amazon's fork of MySQL. They could have done whatever they wanted here, and yet they decided to make transport security difficult. Azure, by contrast, handles this much better. It's very clear, both in the documentation and in the portal, how to accomplish this. The documentation also provides the way to accomplish this in the Azure CLI. Not much else to see here. Bravo, Azure. GCP is also straightforward. You can easily require secure connections using multiple methods that are all well documented. Doing so will allow you to require that the clients, it will require your clients, to provide a certificate, which is an additional layer of authentication that the other providers do not include by default. Alternatively, you can use the Cloud SQL proxy, which creates a secure tunnel from your client machine to one in GCP's network. At that point, Google would argue that it doesn't matter if your client is configured to use SSL/TLS or not, because the traffic would only be unencrypted within Google's internal network. That said, make sure to consult your legal and compliance teams before considering this option, as it is arguably not end-to-end encryption. You could theoretically run your own proxy between your client and the Postgres server, such as PG Bouncer or Proxy SQL on the other providers. For example, I previously implemented PG Bouncer on AWS to enforce SSL/TLS. That, though, is a lot of work and would definitely not be considered secure by default. I think I made it pretty clear why AWS RDS is the worst service in this category. Azure and GCP are pretty close here, but I'm going to give GCP the edge because of how easy it is to enforce client certificates and because of their Cloud SQL proxy, which, if used properly, guarantees encryption in transit. Next, let's transition to talk about serverless functions. For those who are not familiar with the serverless revolution, I strongly recommend that you read up on it. It's taking the development world by storm. Serverless doesn't actually eliminate the need for you to run applications on servers, but it allows you to run small snippets of code without having to think about what servers they are running on or how many resources these servers have. Here's basically how it works. Some event happens in your system. This could be an HTTP request, the detection of a particular log message, or anything else. Afterwards, the cloud provider will provision a container, load your code into it, and execute the code. After a minimal amount of time, this container will be destroyed. This is a great movement for agile product development. And guess what? It's also a great movement for security. No long-running servers also means no long-running command and control channels. That being said, of course, with every new technology, there will be security concerns. We will talk about 3 of these concerns today. First, we're going to discuss how to trigger functions over HTTP, as this is one of the more popular use cases for serverless. We will also discuss each provider's API gateway offering, although, as you see shortly, AWS's API gateway plays a fundamentally different role than the other 2 here, and we'll see why in a moment. Let's start with AWS Lambda. You can invoke Lambdas over HTTP using either an API gateway or an application load balancer. We're going to focus on API gateway because this was the first option supported and the one that most developers choose by default. The user interface for setting up a Lambda with API gateway has changed dramatically in the past few months. In early December, AWS introduced the ability to create HTTP-triggered Lambdas using a template directly from the Lambda console. As you can see, if you use their beta template for the HTTP API, you are forced to make your API wide open initially. That security dropdown is grayed out. You have to reconfigure the API gateway in a separate console to add security, which is unfortunate. Of course, as this feature was introduced during reInvent and was likely quickly shoved out the door, it has changed since. Now you have to create a gateway from this template in the API gateway console. They've since eliminated the grayed out Dropbox for security. By that I mean to say they eliminated the security section altogether. You once again have to create the API before configuring authorization. Because this is once again beta functionality and is likely to continue evolving, we will assume that the developer is aware that authorization is a thing and does at least some due diligence to actually try to configure it. API Gateway requires HTTPS by default. In order to invoke a Lambda over an insecure HTTP connection, you have to do so using CloudFront, which is so much effort that you better have a good reason to require unencrypted traffic to implement it. It has multiple different authentication and authorization options, including AWS IAM, API keys, and custom authorizers provided by Lambdas. API gateways theoretically can also be made private and inaccessible from the public internet, but this functionality is very poor in my opinion and worthy of an entirely different talk. Feel free to ask me about this during the Q&A so I could rant about it endlessly. Unlike AWS Lambda, when you want to invoke an Azure function via HTTP, you don't need to set up any additional infrastructure. You automatically get a function URL, which is convenient but has security concerns. Having an API gateway allows you to enforce a single choke point for your security. Even though you can front your function using Azure's API management depending on your authorization level, you nonetheless cannot turn off the original endpoint. I was very surprised to see that. And in addition to that, I was very surprised to see that the endpoint can be accessed over both HTTP and HTTPS by default. Thankfully, you can easily turn off HTTP access, although the typical developer is unlikely to think to fix this, let alone test it in the first place. With regards to permissions, by default, functions require a significantly complex API key for authentication. You can additionally configure a function to be invoked anonymously or via your master key. By default, functions can be invoked from the public internet. However, you can use network access restrictions to allow the API management service or Azure Front Door to access your function. And if those are private, your function will effectively be private as well. This isn't super intuitive, but neither is the setting up of a private API gateway in AWS, so I won't harp on them too much for this. This also allows you to use the API gateway as a single choke point for enforcing security, but this is not easy to set up, so I definitely would not consider it default security. Google is in a similar boat. You automatically get an invocation URL, which has the same advantages and concerns as before. There's a beta integration between Google Cloud Endpoint and Cloud Functions, but you still can't turn off the original endpoint. Just like Azure, you can invoke your function over an insecure channel, but even worse, there's no way to turn this off in the platform. The best solution I could find was writing logic into the function itself to perform a redirect, which is not something a typical developer would ever think to do and has security concerns of its own. By default, functions can be invoked without authentication. However, this is fairly noticeable in the function creation form as shown here. Even if you purposefully created a public function, you will get a warning message every time you edit it that says, this resource is public and can be accessed by anyone on the internet. Unlike AWS and Azure, there's no way to restrict a function from being called from the public internet. Again, although this is technically possible in both AWS and Azure, it's really convoluted, so all three providers could definitely improve here. For these reasons, I scored each provider like so. Next, let's talk about how we manage our functions using various user interfaces provided by the cloud providers. You have a couple of options on providing your code to AWS Lambda. Simple and safe, nothing to see here. Google Cloud, very similar as well, no concerns. Okay, for Azure, you can only edit the code inline from the portal. Well, that's annoying, but it's not really a security concern, but wait, what is this? By default, you can deploy Azure Functions over not only FTP, but an insecure FTP connection. Yes, you need to provide credentials, and responsible people should use clients that require a secure connection, but even still, this is going to be a huge red flag in your audit findings. Thankfully, you have the choice to turn off FTP-based deployment, or at least require secure connections. Still, if you don't know to look for this setting, and few do, you'll allow insecure FTP-based deployments by default. Additionally, note that there are some other ways of deploying the function that don't come from the portal, but unfortunately, we're only as secure as our least secure option. So it's pretty obvious how I determined these rankings. Lastly, let's talk about the default permissions given to the various cloud functions during execution. Lambda uses the same IAM policy model that AWS uses for many of its other services. In order to run Lambda, we have to give it an IAM role. So this is the default selection on the wizard for creating a Lambda in AWS. This perked my interest. Create a new role with basic Lambda permissions. Basic Lambda permissions, eh? Let's just see about that. So it turns out, actually, it's pretty basic. The execution role doesn't do much. All it allows you to do is create a log group and write CloudWatch logs to it. This seems pretty reasonable to me, as these logs will be useful for auditing purposes. Azure is even more limited. By default, the functions don't have permission to access any Azure resources. You must explicitly associate an identity with the function in order to change this. GCP takes a far inferior approach. By default, it will use the default App Engine Service account, which has the editor role. This means that if your function is compromised, you will have read and write access to almost every resource in the account. In some cases, you'll even have create and delete access. Editor is the second most powerful primitive role, right behind owner, which can do everything that the editor can do, plus manage roles and billing. The documentation states that we can limit or extend the permissions of this service account. But one, who in the world would want to extend it? Why would you want a function that changes your billing options? And two, this is extremely easy to overlook when you're just trying to get started up on Google Cloud Functions. Another SANS instructor and a friend of mine, Eric Johnson, proved that it is possible to read the contents of all storage accounts using the execution role. Thankfully, he determined that he could not access the secrets manager. That's because individual secrets also need to list which accounts can read them. This is a nice safeguard, but we don't know how many services follow this permission model. So we end up with these ratings. So when evaluating the limited topics we've discussed today, here are my final scores. The rankings aren't shocking, as they basically match those provided by the Gartner's Infrastructure as a Service Magic Quadrant report. For those who are more visually inclined, here's a radar chart summarizing today's findings. Just a reminder, this slide deck will be published shortly after the webcast concludes, so feel free to examine this data further in more detail. So what have we learned? First, I hope I have convinced you that security defaults matter. Even if you know how to use these services perfectly, you can't depend on your organization being as informed. These design choices from your cloud providers have a real material impact on your organization's security posture. When our cloud providers fail us, as always, education is key. The users of the cloud in your organization need to know what they're doing. I'm not just saying this because I teach SANS Sec 540, but on that note, you should totally take SANS Sec 540. Beyond that, teach your developers to scrutinize new services and functionality before adopting them. Don't be magpies. Newer offerings are likely to have the biggest security flaws or weak default security security configurations. For example, at one point, when you created an Aurora database using the dev test template, it was public by default. And this was basically right after Aurora was launched. It was fixed after we complained about it. And this shows that they will listen if you make enough noise. And of course, don't make presentations the week of reInvent. I really got started with this presentation during the week of reInvent 2019, and already I've had to make so many updates because things are constantly changing after reInvent. If you'd like to fact check any of this presentation, please do. Here are my sources. If I got something wrong, please let me know so I can avoid spreading misinformation further. If you enjoyed this talk, I welcome you to attend my next one. This talk was fairly serverless heavy, as this is one of the areas I'm most focused on recently. I'll be speaking at Serverless Days Nashville next month on how to pilfer a serverless runtime to pivot through a compromised account. This talk is based on research that I have been doing with Eric Johnson, another SANS instructor. He will also be doing a talk on this subject around the same time at the RSA conference, focusing more on the defensive side. My talk will be archived afterwards, so you can watch it online. I'm not certain of his talk just yet, but of course, I also welcome you to check out my original article on Amazon RDS security. It goes into way more detail on that specific topic than we had time to discuss here today. One more thing, just yesterday, AWS launched a new webpage called AWS Security Documentation. I mean, literally 24 hours ago, they launched this. It's a directory of security guides broken down by service. This was a long overdue feature and should certainly make for some good additional reading. I have a lot of people to thank for their help with this talk. Thanks to Eric Johnson and Frank Kim from SANS, Chris Mankin and Charles Smith from Asurion, and Ross Young from Capital One for your many great feedback and ideas. Thanks to my former director at Asurion, Nick Choate, for encouraging me to write my original article on hardening RDS, which led me to create this presentation. And most importantly, thank you so much for taking the time out of your day to listen to me. I hope you enjoyed the talk. Much of it was subjective, so I'm sure you'll have some differing opinions from me. We will now send out 2 polls asking which provider you think best provides the default security and which one provides the second best. If you'd like to share some alternative viewpoints or discuss other interesting security defaults, I'd love to hear them. If you have general questions, that's also welcome too. And with that, I'll hand it back to Carol.
Currently launching the first poll, so we'll go ahead and let that go for a few more seconds now. Then I'll close it, and if you want to speak to the results, feel free. Otherwise, I'll move on to launch the vote. All right, I'll go ahead and share the results before I launch the next one, Brandon.
So not very surprising, folks followed along with the talk, and in general, AWS is just the most mature at this time, but Azure is really catching up, and GCP is doing a lot of good things, just not consistently. So this makes sense that those would be the results.
I'll go ahead and launch the next one. Close to half the people vote. Close this poll. For those results, go ahead, Brandon.
Awesome. Thank you so much for your feedback. And now I am welcome to questions.
Go ahead and hide that. Okay. So our first question, oh, and anyone who does have questions for Brandon, please enter it into the questions window at any time. It says encryption, oh, excuse me, just a moment, please. Encryption for data at rest scenarios in all cloud providers imply that the cloud provider can access all the data in plain text. For example, rogue employee or hacked cloud provider scenarios apply and allow this data to get leaked. True or false?
That's a great question. As far as I understand, yes, absolutely. The cloud providers have no way of preventing themselves from accessing the key management services for their various providers. So technically, yes, they could definitely decrypt their own data, which is why a lot of folks are uncomfortable with the key material being generated in the cloud, because then you don't have the same kind of auditing that you would get from an on-premise key. So yeah, it's really more of a compliance thing. I don't think it provides a whole lot of true security, to be honest with you, but I know from experience that compliance folks are very big on that topic. But it's a great point. Thank you so much.
All right, thanks. Before the next question, you've got some feedback. Thank you. Great and valuable webinar. Someone else says, excellent presentation. Thank you. Awesome. Thank you so much. The next question is, what was the name of that new AWS resource page again?
The new AWS resource page. I have it in my notes. Just give me 2 seconds. I'm going to double check. It's called AWS Security Documentation. It just came out. Their LinkedIn just announced it about 24 hours ago. It's not really new data as far as I understand it. It's more of just a compilation of the security details per category and per service. So very helpful for us to look up data when we're exploring a new service, but probably not new content at this time. But hopefully that gives them the incentive to go further and provide even more documentation.
Let's see, someone says, where can I download the brief? I put it in the chat window. A copy of the slides and recording of this webcast will be available for viewing later today. Page. If that's not what question you're asking, please reach out again. Okay, so someone asks, do you have any recommendation for secure design patterns for deployment, such as CloudFormation for AWS?
So I think that CloudFormation is a very useful tool, but I think like everything else, it's all about your usage of those tools, right? So if you have CloudFormation and you're utilizing it perhaps from a CI/CD pipeline, you know, that could be great. But if your CI/CD pipeline itself is insecure, let's say you're using Jenkins and you allow anonymous login access to Jenkins throughout the entire world, that would be a really bad day, because now you're providing a hacker the ability to provision any infrastructure that they want. We provide a lot of detail on how to use CloudFormation in Sec 540, but a lot of our focus on security is on the individual services, not the security of CloudFormation proper.
You addressed this a moment ago, but correct me if I'm wrong. They said, where's the AWS guides you mentioned? And then they put in parentheses a link.
Sorry, still getting used to these microphone controls. Once again, the name of the document is called AWS Security Documentation. I don't have the link offhand, but if you go to their LinkedIn page, they posted it, I believe, around 24 hours ago.
And it looks like another attendee is assisting with that, sent the link over. Chat window, so if I want to asking.
I'm sorry, can you repeat the question?
Oh, I was posting the link. A couple of people have sent that Amazon link that they were wondering about, so I put it in the chat window just now. Best tool to audit Azure.
Gotcha. Thank you for that.
What's the best tool to audit Azure security configs?
That's a great question. I am not super familiar with configuration management scanning for Azure. I know that you can use, if you're using Terraform, for example, you can use some linting tools, but they're not very comprehensive and they're not necessarily specific to Azure. So as far as I know, that tooling isn't really there. I know that for CloudFormation, there's a tool called CFNNAG, which is pretty powerful. And then there are some other tools such as Cloud Mapper and Cloud Custodian that will actually look at the resources that exist in your account instead of just looking at the configuration associated. So those are the tools that I'm aware of for AWS. I unfortunately am not as familiar with Azure, but I think one of the folks that I've talked to said they actually don't have something like that yet.
Thank you. Scanning or linting tools that can be used to validate security settings on the various providers. For example, there is a cube_bench for scanning K8 cluster against CIS benchmarks. Is there anything similar at the cloud infrastructure level?
Yes, so I mentioned this previously. There's one for CloudFormation specifically called CFN_NAG. That is a tool for auditing the CloudFormation code for security vulnerabilities. But there are some other tools that can examine the cloud itself. But if you want to do static analysis purely just looking at the configuration files, start out with CFNNAG.
Another long one, regarding encryption key generation and storage, your thoughts on multi-tenant key vaults or engines with a single tenant/user HSM hardware security module on the back end?
That is a great question and one that I certainly don't feel like I can answer very accurately. I am not in compliance. I come from a developer background, and to me, I want to make things as truly secure as possible without going overboard for, let's say, the purposes of compliance. I know for a very long time, for example, KMS wasn't able to call its underlying infrastructure and an HSM because of it not actually matching regulation. To me, I'm not nearly as concerned about that because I think the likelihood of a key being compromised in AWS is just very, very, very unlikely. And if it were to happen, our organization would probably not be the first company affected, or the only company affected, certainly. So I can potentially, if you reach out to me, I know a lot of people are really well versed in this topic, including my boss, who actually wrote the section on key management for the Sec 540 coursework. But I offhand don't have much more than that to mention.
Okay, thank you. GovCloud versus public, is this really a significant security upgrade?
I missed the first word of that question.
GovCloud versus public.
Got it. Not to be confused with CloudGov, which is what I initially went to. I do not work in the government sector. I'm not super familiar with GovCloud beyond the fact that GovCloud takes a much longer time to vet its services out and introduce them. So there's a lot of things that I know my friends would recommend to someone who is working in that industry, and they would say, we can't even use that service yet because it hasn't been approved yet. So I'm not sure what other security controls they implement, but I know that they have a much smaller pool of services available in GovCloud.
Of the three providers, which has the best key rotation policy?
Definitely something I need to research further. I know that AWS's key rotation policy is pretty easy if you're using a managed key, but basically impossible if you provide your own key material. So again, I'm not as involved in the compliance side, and I know that the rotation happens enough that we're in, a good place. But I would have to research further on the other two cloud providers.
Thank you. From an incident response perspective, which of these CSPs provide more resources? Any good reference from your experience?
Which of them provide the best documentation?
They said which
Was
of
that the
these
question?
CSPs which of these CSPs provide more resources?
Okay, so in this case, I'm assuming you mean resources as in documentation. Of the ones that I've looked at so far, Google Cloud is really good at documenting not only the steps to secure your infrastructure, but it also gives you commands that you can utilize. So I've really been enjoying working with Google Cloud in terms of using their documentation. Azure, close second. AWS really needs to catch up, not because they have bad documentation, but they have so much that it's hard to find the good documentation, unfortunately.
What about SLA covering what you need with vendors?
Don't do a lot of work interfacing with vendors, so I would need some more context on that question.
All right, thank you. Do you see the cloud providers moving forward on using TLS 1.3, which is now published, RFC 8446, instead of TLS 1.2 to add that extra layer?
I see no reason why they shouldn't. I mean, really, everything that I've heard about concerns about encryption in transit have all been about overhead, and I think we're just well past the time period where that's a serious concern. So I know that people have been moving from 1.1 to 1.2. I see no reason why they wouldn't also introduce 1.3 unless there's some other overhead that I'm not familiar with. So I'm sure they'll get there eventually. I mean, they want to match as many customers as humanly possible, so they have every incentive to support as many protocols as the customers desire.
Since it is so easy to move laterally between cloud instances, say within AWS, is the only way to ensure minimum security levels is eyeball instance by instance?
So that's a great question. I think that a lot of it comes down to managing your instances in a consistent way using infrastructure as code. In addition to that, as I mentioned, we're going to be talking about how to lock down serverless functions in a similar way next month at Serverless Days. And a lot of it's just about having good IAM policies, right? Because if you compromise a single box, yes, you may be able to pivot within the network if you have bad security groups, but if you have really, concise IAM policies, then there's a very limited amount of things that can be done. So my understanding from the Cap 1 breach that happened last year is, although there was a security flaw that existed in the application, the damage was severely multiplied by the role being overly permissive. So I think there's a lot of work we can do in terms of enforcing IAM policy across our accounts. And there are a variety of tools you can do to utilize that, such as mentioned before, CFN-NAG for looking at the infrastructure as code, using Cloud Custodian to look at the infrastructure as it exists in the account, and then Cloud Custodian can not only detect issues with your configuration, but they can also undo some of those bad settings. So if you give it overly permissive IAM roles, it can revoke them. So there's a lot of different ways we can work on this, but a lot of it comes down to consistency and locking down our IAM policies.
What's a good pen test platform for cloud?
So, not to keep deferring to awesome SANS resources, but SANS is developing a Sec 588 course, which is all about cloud penetration testing. That being said, I'm very happy that unlike in the past, AWS, you can do penetration testing without any approval from AWS. So from my personal experience, a lot of the tools that I've been using have been the same ones that I use for just normal websites. I mostly do web application penetration testing myself, but I would use Zap, I would use Burp Suite, I would use a variety of other tools that are pretty traditional. I know that there are some other tools that are cloud-based that you can use for like dynamic analysis. And I also know that there's a lot of tools that you can use to attack particular cloud services. One in particular that's really interesting to me is this tool called GitRob, which will take a repository that you have access to and try to find all of the high entropy strings that may be credentials so that you can use those to pivot throughout the account. So I hope that answers your question.
Your worst experiences regarding serverless computing in terms of security?
I think it really comes down to IAM policies, right? In theory, an IAM policy can be handcrafted for a serverless function and be perfect and only have the necessary capabilities that the function needs. Unfortunately, if you have an organization of hundreds, if not thousands of serverless functions, it's really difficult to convince developers that it is a useful part of it's useful for them to make an individual policy for every single function. And a lot of the automation tools that I've seen make it difficult to have individual IAM policies. So that's generally the issue that I find is I'll see that there are IAM policies that are applied to Lambdas that absolutely don't need those permissions. But in a world where we can automate this away a lot better, we have a lot of potential with serverless, right? Monolithic service or a microservice even has to access way more resources than an individual Lambda does. So if we can automate the process of creating those policies, we're actually going to improve security in that dimension. Another thing that I'll mention real quick is regarding persistence. There's the belief that serverless functions do not persist the containers at all. And if you look into it further, that's not the case. In order to prevent serverless functions from being incredibly unperformant, they have what's called a cold start and then a warm Lambda. So the cold start warms up the Lambda so that subsequent requests will be faster. And that means the container is going to live as long as necessary until the next cold start. So if you're aware of this, you can do some pretty damaging things in terms of persistence. And a lot of developers do this for us because they have this thing called a warm-up plugin that they use to purposefully keep the Lambdas warm. And it's just like a invocation of the function every minute or so. And that is good for performance, but bad for persistence. You've now thrown away that benefit.
The tool for auditing, CFN?
Yes, CFN, which stands for CloudFormation, and then there's _nag. CFN _nag, N-A-G.
All right, thanks. What standard things should we ask for in contracts?
With regards to contracts with the cloud provider, not sure I have a lot of useful information here, but I think one of the things that was mentioned earlier that I think is relevant here is contractually, at least with AWS, we are able to do penetration testing on infrastructure in the cloud that we own. And that's really useful for being able to, figure out things like security issues like the ones we've discussed today. So I would certainly make sure that whatever provider you go with provides a clause like that to allow you to self-validate a lot of these things.
All right, thanks. We have two more. Redshirt AWS used to secure their TLS certificates signed with SHA-1. Has your research looked at not just the configuration defaults, but also the exact implementation for using decent algorithms and key lengths?
I have not looked into the certificates generated and what algorithms are utilized. If they're using SHA-1, that's very bad. I know that much. But in a lot of the use cases that I'm working with, we actually don't generate the certificates in AWS. We import them. So that's definitely a good call out, though. There's if by default certificates are provided with the SHA-1 algorithm, that's really, really bad. And I would be upset to see that. So please message me on some social media like LinkedIn with those details, because I'd love to read more.
All right, and our last one, what about Azure Bastion for access?
Azure Bastion, I don't have a lot of firsthand experience, but it sounds pretty similar to the proxy service that I mentioned before on GCP, which allows you to make a connection directly to your cloud provider prior to pivoting to the individual service. So that seems like a pretty nice strategy, because you can enforce in-transit security at that uniform level, but don't have a lot of firsthand experience with that.
All right, well, that's all we have for today. Thank you. Okay, great. Thank you so much, Brandon, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcast. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Thanks, everyone.